Hi class, we continue our lecture about Saturn. Okay, so previously we have learned about the rings, okay, the rings in Saturn. And now we continue for the next slide, is slide 32. Okay, about the radial spokes. Okay, let me just try to, okay. Okay, so a series of dark called radial spokes were observed on the B ring. Okay, disappeared after one ring orbital period. Okay, so about micron size dust, okay, 10 meter above the plane of the rings held in place by electromagnetic forces generated in the ring plane, okay, here, resulting from collision among particles or interactions with the planet's magnetic field. Okay, so the Cassini division contains a series of faint ringlets, gaps, and embedded moonlets. Okay, and has the other division in Cassini called Mimas, okay, the closest major moon to Saturn. And the resonance of these particles complete exactly 2 orbits around Saturn in the time taken for Mimas to orbit once, 2:1 resonance. And this resonance causes the particles to receive a gravitational tug, okay, from Mimas and turning their circular trajectories into ellipse. Okay, so for the orbital resonance and Shepherd satellites, okay, about the particles. Particles is non-resonant orbits are also act upon by Mimas gravitational pull, but the tugs are spread and cancel out. The sharp outer edge of the A ring is governed by 3:2 resonance, with Mimas predicting that the ring system should spread out with time. However, the A ring's outer edge is patrolled by Atlas, a small satellite held in place by the gravity of Mimas, which prevents ring particles from diffusing away. Okay, so the latest finding about the F ring, okay, distance of 3,500 kilometers from the A ring, okay, 3,000, almost 3,000, okay, from the A ring, unusually narrow, less than 100 kilometers wide, is centric in shape, okay, here, in shape, and has irregular braided structure. Okay, this is the moon called Shepherd. Okay, due to two Shepherd satellites that orbit on either side of it. Okay, it has two dark satellites called Prometheus and Pandora. Okay, each of it 100 kilometer in diameter and orbit 1,000 kilometer on the either side of the F ring. Okay, the gravitational influence of the F ring particles keeps the ring tightly confined its narrow orbit. The G ring, on the other hand, does not have ringlets, but it is relatively narrow. Okay, and G ring has arcs, regions of enhanced brightness that move in resonance with Mimas and harbor confining moonlets. Okay, so most likely the result of micrometeorite impacts ejecting material from those small bodies. Okay, so the origin of the rings, there are two possible origins have been suggested for Saturn's rings. Okay, first one is satellite with diameter 250 kilometer, and the second is material left over from Saturn's formation stage 4.6 billion years ago. Okay, since all the dynamic activity observed in Saturn's ring suggests that they are quite young, okay, less than 50 million years old, it is somewhat impossible for them to remain stable for billion years. So if this is so, then either the rings are continuously replenished, okay, replenished with a fragment of the moon or activity on the larger moons, or they are result of a relatively recent and catastrophic event. Okay, to make things more complicated, Cassidy found the different rings may have different age and may even have formed in different ways, suggesting that the catastrophic event probably played important role. For now, the original Saturn's ring isn't known. Okay, how about the moon of Saturn? It's the most extensive and complex system of natural satellite of all the planets. Saturn has 8 major moons. Okay, this one is Mimas, Enceladus, Cepheus, Diode, Rhea, Titan, Hephaestus, and Lepidus, and all about more than 300 kilometers in diameter. Most are covered with snow and ice, and probably made almost entirely of water ice. There are 82 known moons orbiting Saturn as 2019. Most of these moons are very faint, small, large, and inclined orbital, and often retrograde. Okay, the retrograde motion. Okay, we have learned about the retrograde motion before this. Okay, so this is the detail. Okay, properties of the 8 major moons of the Saturn. Okay, as you can see, the distance, orbital, period, size, mass, and density. Okay, so we can see in this figure all the moons which closest to the Saturn. Okay, so Mimas, the arrangement is like this. The Mimas, Enceladus, Cepheus, Diode. Okay, yeah. Okay, so we can see the arrangement from the outermost layer of the ring. Okay, after that is followed by the Mimas. Yeah. Okay, this is the list of all the moons, okay, actually observed or discovered in Saturn. But the main we should know is 8. Okay, 8 moons. The moons fall into 3 fairly natural groups. Okay, small moons, medium-sized moons, and the Titan. So the small moons is irregular shaped chunk of ice, diameter less than 400 kilometers, and exhibit variety of complex and fascinating motion. But for the medium-sized moon, okay, Mimas, Enceladus, Cepheus, Diode, Rhea, Hephaestus, so 2, 3, 4, 5, 6. 6 is classified as the medium. It's a spherical body, diameter about 400 to 1,500 kilometers, and offer clues to the past and present state of the environment of the Saturn. And the third one is Titan. Okay, so the Titan is the largest and most interior ring of all Saturn's moon, discovered by Christian Huygens, visible through a large Earth-based optical telescope, okay, and barely resolved reddish disk, has a red atmosphere, denser than Earth, a thick and uniform layer of haze, and is made up of 98% nitrogen, 2% methane, with traces of argon and other gases. Okay, so this is the we can see the distinct layer of consists in different altitude in Saturn. Okay, so we can see here the methane clouds, okay, followed by aerosol haze, main haze layer, ultraviolet optical, and ultraviolet absorbing haze. Okay, the organic molecules, below the haze layers have been detected, and the Titan contains 10 times more gas in the atmosphere than Earth. Having atmospheric pressure 60% is greater than the Earth and ground level. So the Titan mass is less than twice of our moon, okay? And the Titan atmosphere extends 10 times farther into space than Earth due to its weaker gravitational pull. And the top of the main haze layer lies 200 kilometers, okay, above the surface. Below the haze, the atmosphere is gloomy because little sunlight gets through. Okay, and also the methane, ammonia atmosphere that release and trap gases, okay, to form this thick methane. Sunlight split ammonia into hydrogen and nitrogen, while methane is more tightly bound and survive intake. However, the Titan's atmosphere is steadily escaping due to the constant buffeting by Saturn's harsh magnetosphere, which means it will have 5 to 10 times denser in its eastern parts. And then the infrared image of Titan's surface show light and dark regions to be patches with hydrocarbon tar. Ridges and cracks on the moon's surface suggest that the Titan cracks may be common. The low amount of cratering suggesting that erosion is occurring. The current models suggest that rain may be a seasonal phenomenon, falling in winter and evaporating in summer. Okay, still in the Titan surface and the interior structure, okay. So in the Arequibo detected liquid hydrocarbon legs on the Titan surface. Okay, the hydrogen skid landed on the ice Earth landscape and found what seems like a network of drainage channels leading to shoreline. Okay, as we can see in this figure, a very detail of the feature. Okay, in their skin landed. And Cassidy also captured the radar image showing numerous lakes. Okay, here the dark area, which confirm the presence of the liquid ethane in the lakes. So the methane rain feeds the lakes, but it's much more volatile than ethane, therefore evaporate rapidly, leaving heavier hydrocarbon behind. And the computer models indicate that the lakes are 75% ethane, with 10% methane and 7% propane. Okay, now is the interior, the interior structure of the Saturn, of the moon of Saturn. Okay, it consists of rock ice core, high pressure ice, liquid water, near surface ice, and the surface. Okay, so no wave have been detected on the lakes. Okay, and the presence of heavier tar like hydrocarbon with high viscosity. There are significantly lesser number of lakes observed near Titan's south pole, suggesting that lakes grow during the rainy winter season. Okay, how about the Saturn's medium-sized moon? Okay, we have I think 6, 2, 4, 5, yeah, 6 moons in this medium size. Okay, so all of it were detected from the Earth-based observation. Okay, we can see the different size in medium-sized moon. The inner 5 moons move on nearly circular trajectories and all tidally locked into synchronized rotation. Sorry. The density of these 6 moons, okay, is range 1000 to 1400 and do not show any correlation with distance from Saturn They should all be composed largely of rock and water ice, just like Titan. Density lower than Titan probably because their small masses produce less compression of their interiors. Okay, heavy cratering indicated uh, cluttered and violent planetary available in the early solar system. Okay, now we go one by one into Rhea, the largest of the six moon. Okay, this is the characteristic. Okay, water ice surface, highly reflective, all surface with no evidence of extensive geological activity, has a wispy terrain, okay, and also ice cliff created by tectonic fractures, and only has leading size, only craters on its leading side. And second one is Tethys and Dione, comparable to each other in size, have mass somewhat less than half of the mass of Rhea, reflective surface. Okay, and this Dion's trailing face has ice cliff. Okay, and considerably more recent than the period of heaviest bombardment. And Dione has also Maria, where all craters were flooded and covered. Tethys, on the other hand, has cracks, which may be tectonic fracture or the result of a violent impact. How about the Mimas? In the most and smallest medium-sized moon, only 1% mass of Rhea, and causes resonant interaction with the ring particles, heavily cratered, okay, and has enormous crater called Herschel on the leading face. Okay, now the Enceladus, okay, very nice, huh? They put the color and the craters here. It has a bluish in color also here. Okay. Has a size mass composition and orbit similar to Mars. Very bright and shine. Okay. Has a surface completely coated with fine crystal of pure ice. Okay, so that's why the color is like this. Okay. It's a fine crystal of pure ice. Bears visible evidence of large-scale volcanic activity and devoid of impact craters as they were erased by water now frozen. Okay, Enceladus was found to have Earth-like plate tectonics, okay, near its south pole. Okay. Okay, the E-ring is known to be densest near Enceladus. Volcanism on Enceladus may be continually supplying new particles to the ring. Okay, since the ring was found to be unstable due to the destructive effect of the solar wind. The ice jets emerge from geysers near the Enceladus south pole. Okay, and a transient water vapor atmosphere exists surrounding Enceladus denses around the south pole. However, continues to escape from its weak gravity yet steadily replenished by the geysers. The orbital resonance and most activity on Enceladus is considered on the south pole, which is actively several Kelvin warmer than the equator. Okay, Iapetus, the outermost mid-sized moon, orbit centered on somewhat eccentric and inclined orbit, has two-faced moon, and has a giant 20-kilometer height, 1,400 kilometer long reach spanning half of its circumference. And the dark deposits in the solar system are usually thought to be organic, produced by the solar radiation by hydrocarbon ice. Okay, wow, this one is a new yet very diffuse ring. Okay, 6 billion kilometers from Saturn, was discovered in the infrared by Spitzer Space Telescope (SST), and this Jupiter lies at the inner edge of this ring. The steady accumulation of free particle cloud naturally account for the moon's asymmetric appearance. Okay. Okay, the small satellites. The masses of the Saturn's small moons are poorly known by are thought to be similar in composition to the small moon of Jupiter. Most are less than 10 kilometers across. Okay, so the example is Hyperion and Folk, okay, the largest one, and have all been discovered in the late 90s. Okay, and we have Janus and Epimetheus, 10,000 kilometers beyond the Earth ring. They are co-orbital satellites, which means they share an orbit in a strange way. Both are have circular orbit, but one is slightly smaller than the other. Okay, so we can see here the small satellite movement, orbit 1, orbit 2. Okay, so the inner moon moves faster and takes 4 years to lap the outer moon. Okay, when they get close enough to feel each other's weak gravity, they switch the orbit. So there may have been a single moon that has broken up after meteoritic impact. Okay, and we have Callisto and Calypso. Is have synchronized with the orbit of Tethys. Always lies precisely 60 degrees ahead or behind the Tethys. And we have this Helen and Polynices are similar type to Dion. Here, Helen. Yeah, this is the Callisto, Tethys, and the Calypso. So these 4 moons of small satellites are known as Trojan moons, while the 60 degree points ahead or behind are known as the Lagrangian points. So there are 2 different uh, classification. Okay, so recap for this chapter. So you are actually have learned about the orbital physical properties and compare them with those of Jupiter, composition of structure of Saturn's atmosphere and interior, and also the internal heat source and magnetosphere Saturn, structure of composition of the Saturn's ring, okay, the Roche limit and relevance to the origin of Saturn's ring, general characteristic of Titan, and last one, some of the orbital and geological properties of the Saturn's smaller moons. Okay, that's all. Thank you.